bisa digunakan untuk kepentingan penyelamatan dunia. Wah, ini ceritanya cukup menarik. Nah, apa sebenarnya yang melatar belakangi ini? Nah, ini sebenarnya untuk tujuan dari penugasan ini adalah mengajak rekan-rekan untuk berpikir lebih besar, kalau bahasa saya, dibanding dengan kita membicarakan algoritma atau banyak hal technical di ilmu komputer yang hanya sekedar technical matter semata. Tapi lebih dari itu sebenarnya ini bisa digunakan untuk banyak sekali hal yang sangat luar biasa di dunia ini. Nah, ini saya juga impress gitu ya dengan teman-teman karena submission-nya ternyata cukup bagus ya. Jadi ya dari 80 orang 50% plus lah gitu ya yang sudah mengumpulkan. Jadi yang merasa belum mengumpulkan silakan karena nanti itu akan menjadi salah satu poin bagi rekan-rekan untuk mendapatkan nilai yang lengkap begitu ya. Baik, tanpa berlama-lama saya ingin lebih banyak nanti di sesi ini kita berdiskusi bersama ya. Jadi nanti materinya nanti kita selipkan di setiap diskusi dan ini saya akan mempersilahkan kalian atau rekan-rekan sekalian untuk bisa sharing. Nah, ini mekanismenya nanti adalah secara voluntary saya akan memberi kesempatan siapa yang mau mempresentasikan. Bagi yang mempresentasikan akan mendapatkan nilai submission full ya, dalam hal ini nilainya 100 ya. Baik itu salah atau benar itu nilainya 100 karena dia punya effort untuk mempresentasikan. Tapi kalau yang baru submit, nah nanti kita lihat isinya seperti apa, baru kita lakukan penilaian. Jadi bisa dapat nilai 80, bisa dapat 60, bisa juga 100 kalau bagus ya. Nah, jadi kalau yang ingin dapat nilai 100 full, nah silahkan nanti bisa bisa mempresentasikan ya. Ini saya kasih waktu dulu, siapa yang mau mendapatkan nilai 100 untuk bisa dapat full mark di tugas ini, ya, sehingga kemudian mempresentasikan apa yang sudah disubmit. Atau mungkin ada yang belum disubmit tapi mau dipresentasikan juga boleh. Silahkan. Ya, bukan Oh yeah. So today is our agenda is to discuss with the presentation, the submission of presentation that you already done. Yeah. So you're looking for the algorithm to save the world. Yeah. So give your insight about it and then present to us and share with us. Yeah, with your friend too. Okay. So please, student, anyone want to be volunteer first?
Can I volunteer, sir?
Yes, Nadira, thank you very much.
Yeah, okay. Let me just share
I
my
will
screen.
note for you. You already have the full mark, yeah?
Yeah, thank you, sir. Thank you for the opportunity.
Yes. Yes. For you that want to present, you can type your name in the chat and then we will use for the list, yeah? Thank you.
Can I start, Moses?
Yes.
Okay, thank you. Hi, everyone. My name is Nadira. I'm from the International Undergraduate Program, and I would like to present you my presentation about how structure for motion can save the world of archaeology. So first, let us discuss about what is structure for motion. So structure for motion, or SFM, is a computer vision algorithm that can construct a 3D model from a collection of 2D images. For this archaeology issue, we will look more into multi-view SFM. And here's a really short process of how it's done by a two-view SFM, just for simplification. So first, we need to get the key points from the two images by using a safe descriptor, for example, which is an algorithm used to detect and describe local features in digital images. And then once there's a match, we can use a fundamental matrix, which will get the relationship between any two images of the same scene that constraints were the points of projection of points from the scene that occur from the images. And once we found the matches, we will use essential matrix to compute the correlations from the data from this fundamental matrix, which will result in a matrix called with with points of R and T, which will be in data cloud points, which we will use this and create a triangulation, which will result in these two cameras given from these images, which also, before we actually do the key points, we must make sure that both images are calibrated, which will result here. And here is an example of how SFM works after the key points are completed and everything. If I play this, okay, let's just, so yeah, first take a lot of images, and then we can identify the points detected using edge corners or a safe descriptor as I described earlier. Yeah, and then the corresponding points. And this is an example of the triangulation. And then here is the result from the corresponding data points. As we can see, there's an image of the castle from the images earlier. And we can actually add like a surface into it, which we can see here. Now, like this. And so next, how can SFM save archaeology? Well, first of all, we all know that from archaeology, we can learn history, and from history, we can learn a lot of things and find a lot of interesting ones on how to implement it on our real life. And so, however, a lot of historical artifacts are fragile and needs extra care. Throughout the years, archaeologists have used several methods to try and conserve artifacts, and the less they need to touch the artifacts, the better. But these methods have been known to be really expensive and can take a lot of time, such as when archaeologists are doing field work, they might need to take hours and hours just to draw on how the site looks like. And so by using SFM, they can take less time as they need to conduct the research and less cost, especially with the example I've explained earlier. When they're on the field, all they need would be a high quality camera, a computer, and well, other than the camera, they can also use a drone to capture the images. And so by doing that, they can construct the artifacts, either it be a building or like a helmet like this one, and so they can do that without doing any damage. And I've actually seen this in museums, and it's really interesting and fun because I can actually see the details of the helmet in full details, including the detailed drawings. So for a non-archaeology student, I find it really interesting, and I actually learned a lot from it. And that is all. Thank you.
Okay.
Are there any questions?
Yeah, that's cool, Nadira, about the SVM implementation, yeah, for the archaeological objects, yeah. So I think it's very related with our situation in Indonesia. We have a lot of candi, we have a lot of archaeological site that already discovered and new discovery, especially in the East Java and so on. So I think that would be interesting because I think the cost doesn't matter because the preservation itself is very valuable, yeah, for the next generation. So what do you think, Nadira? If we use it, and what the value that you will get from the result of the the pointer that collected, and then we get the object in the digital form. What do you think?
Okay, sir. Thank you for the question. I believe that by using SFM and being able to create this a virtual design of what the artifact may be, like for example the Prambanan temple, and I know that the Prambanan temple has been destroyed a few times and being rebuilt. So actually, I read this online when I was taking a module in computer vision. So there's this research team who use these data points to create a 3D print of a statue, of a god statue, I think in Greece or Italy. So I think it might be possible to like create a detailed Prambanan temple. If it's broken, it will be easier to fix because there's like already a digital blueprint that is really detailed, and it might be possible to create a very detailed replica of it, a 3D replica that can be displayed in museums, which can be later learned by future researchers or like students.
Yeah. Okay, thank you very much, Nadira, for the inspiration. Thank you. It's very good. Thank you.
Yeah, thank you, sir.
Okay, we go through to the next. Yeah, I think in the chat we already have the list. The next will be Atri Wicaksono, please.
Yes, sir. Asking permission to share my PowerPoint. Okay. Is it visible now?
Yeah.
Okay. So, greetings everyone. My name is Atri Wicaksono, and here I'll present my my idea, that is to fix one major problem, especially during the COVID pandemic, that is income stability. So I want to talk about layoffs during this pandemic, because getting fired sucks, because especially for a new employees, when they have like a really great planning, they had a house mortgage, they need to pay their student loans, especially people who are from outside of Indonesia, where education are actually expensive. And maybe when you're actually when you don't have a house, when you pay the rent you're living, and maybe you have other installments, maybe like for your jobs you need a good laptop, so you actually bought a decent laptop that's actually pretty costly, or maybe a phone that is actually not the cheapest around, so you did an installment. So yeah, getting fired would just ruin your planning. So my idea is that we can use forecasting methods and pattern recognition. So for the forecasting, one example that I tried is I tried LSTM on top of time series, but I do think that it also possible to implement a similar method to S2F on Bitcoin, which I believe has a 99% accuracy so far. So implementing that, not like a apple to apple implementation, but maybe like a similar implementation into this model, and also backed by the regulation by the government. So for the pattern recognition, we can have like a four signals. So we can have normal, where termination unlikely, low risk, medium risk, and high risk. So my idea is that the employee would be notified 3 months for 3 months prior for possible termination. So the employee would actually be able to prepare for the termination. So maybe they can reassess what they need to learn for their new jobs. Maybe they can take some courses and then get certificates for applications, job applications, or maybe just simple stuff like preparing documents. I mean, who knows? Maybe the new place they want to work on needs like a documents where it is not commonly asked for. So yeah, and the model using pattern recognition, training the model with parameters and back with the time series. So my idea is that for the parameters, we would have the D/E, that is the debt to equity ratio, and the recruits layoff period. So like the periods of when the fresh graduates comes in, and like the circulations, like new people come in and the old people would retire or something. And also the financial trends, because like for example the 98 crisis, I mean it impacts almost everyone in that era. And so after thinking about my ideas, so there are like many improvements that can be done. That is, pattern recognition might not be needed. A simple expert system approach might be sufficient. I mean, but still it's backed by the forecasting method. And also, even though expert system can be applicable, pattern recognition would be more flexible. So just one-time coding, one time in the making, and then it would be it can be used for a way longer time. And also different parameters might be required, like maybe a depth to equity ratio cannot be truly representative to what we need to determine whether there will be further terminations. Maybe I don't know. You guys, please tell me, what do you think can be a great parameters to this idea and other stuffs? Please let me know. And I guess that's all for my presentation. Thank you.
Yeah. Okay, thank you, Atri, for the idea. So I have one question for you. What the main motivation that you try to formulate that income stability will be one of the one of the things that we can solve by implementing the algorithm? What the main background actually?
Okay, so my main background is that uh, I actually likes to. I don't like to plan actually. I like to do everything really quick bursts, like
Okay.
spontaneous. But those people who likes to plan their stuff like into like their fine details, when they get fired, oh, of course they would, their whole plan would be ruined. So I do think that those people would highly benefit from this kind of solution, where I mean it's like an insurance, right? But it is a analog solution to what the insurance company could give us. So I guess this was like at the an extra layer to the income stability. I mean, after the insurance.
Okay, thank you. That's good point, Atri, for your presentation, because you already go further there to see about the one of the issue in the human life that really related with, I think, every decade. Okay, thank you very much. So I think the point of for the improvement, which is we think about the parameter and etc. It will be in the learning process, yeah, for us, yeah, to propose the algorithm that can work with your idea. Yeah. Okay. Thank you, Adri. Good job.
Yeah, yes, sir. Thank you.
Thank you very much. Okay. Okay. So wait a minute. I take a little time to share with you about for the QR. Yeah. Please scan the QR before we go to the next presentation. Okay, for the preparation after A3, we go to Yusuf Dava, I think. Yeah, Yusuf,
Wait, just a moment, sir.
Yeah, let's prepare. Okay, thank you.
Can I share my screen, sir?
Yes, I will stop the presentation. Okay, thank you.
Is my screen visible, sir?
Yes, please.
All right, okay. So good afternoon. Today I'd like to talk about a very simple algorithm actually, that we've all learned during probably our first semester, which is the Dijkstra's algorithm. So what Dijkstra's algorithm? Well, it's actually an algorithm, or one of the algorithms that is used to determine the shortest distance or the minimum cost based on what the weight represents in the given graph. And the procedure for the algorithm is actually very simple. So we firstly identify the current vertex at the end. So the destination will be our current vertex, and then we identify all of the adjacent vertices to the current vertex. So adjacent vertex basically means that any vertex that is directly connected to the current vertex. And then after we finish the identification, we can just simply calculate the weights of the adjacent vertices, of course, with respect to the current vertex. And we have to mark each of these vertices according to the calculated weights. And if, let's suppose, because this is actually an iteration that continuously being repeated until all of the vertices are visited. So every time we calculate the weight, we only update the mark if it's less than the previous ones, because as we said earlier, it's used to determine the minimum weight, or we could actually talk about what is it? The minimum cost, depending on what the weight actually represents. And then after we got the minimum for each of the vertices, we can actually put a label on the current vertex, which is basically the end or the destination that we are trying to get to by putting an X over it. So we can actually simply just cross the current vertex. And then we determine the next current vertex by choosing the adjacent vertices which has the lowest or the smallest weight among the other vertices. And then all the steps are being repeated. All the steps from steps 3 to steps 5 are all repeated until all of the vertices are crossed, meaning that all of the vertices have all been visited. And the applications of this algorithm, even though it's a very simple one, but it has various applications that we are now, using in our daily basis. One of them is the digital mapping services like the Google Maps or Waze, and then we also have the social networking applications. If we look at the social media analysis, usually we determine the connection or the recommendation based on mutual friends and etc. etc. We can also use that with the Dijkstra's algorithm, and we can also obviously use that for the telephone networking and also the IP routing. That is it for the algorithm. It's a pretty simple one, but it has many applications that we are now using in the current days. Thank you very much.
Okay, thank you very much for the insight, Yusuf, with your presentation. I think you also the highlight is the philosophy of one of the philosophy of the algorithm is simple is always the best actually, yeah. So that will be the basic. So I think one of the proof of the evidence of this case is Dijkstra algorithm. Yeah, it's become the fundamentals algorithm. Yeah, for developing the new algorithms. Yeah, even we do some complicated algorithms, but in case in the back to the basic, we need
the fundamental remain the same.
Fundamental things. Yeah. So. I think, thank you, Yusuf. You remind us about the important part of this course, about the computer science philosophy. We need to think deep on the fundamental things, So like now, I think the discussion about the MBKM things and so on, but somehow we think about we want you to have a lot of knowledge here, a lot of knowledge skill and so on, but back to the fundamental. I think you need to be strong on your fundamental knowledge. Yeah, so that will be one of the you need to consider. Yeah, you need to think about. You need to keep with your strong power about the fundamental knowledge of the computer science. Yeah, because if you get that one, you can become everyone, anything you want. Yeah. So thank you, Yusuf. Good point. Yeah. Okay. Yeah. Thank you very much. We go through to Irsan, please.
Okay. Can I share my screen, sir?
Yes, please. Yeah. Irsan. Okay, thank you.
Okay. Okay, so hello everyone. So allow me to introduce myself. I'm Nadir, and today I will be sharing my perspective on how CS can save the world, which I think can be from the Bellman-Ford algorithm. Will tell you why later. So to understand first what is the scope of the problem, what I'm looking is that I see that by increasing the financial capability of one's life, well, we can elevate people's life quality, and by that means we save the world from overwhelming crimes and such. So how do we make money in this case? We basically do a currency arbitrage, whereas means that we convert certain amount of money to different currencies for multiple times. This is just like when we do forex trading. Basically, the idea is that so we can receive bigger money value in the end when we actually invested little in the front. Example can we say like we convert 1000 USD to 950 euro, then we convert this amount to 1020 Canadian dollar, then we convert it back to USD, we get 1007, so we get a plus $7, then this is the profit, and that's the money we make. Interesting, right? However, how does this work in terms of the CS idea or any algorithm related to CS? Well, we model these assets and as directed each a weighted graph. Then we also leverage on the use of negative cycles in the graph. And there we can see the arbitrage opportunities. So how do we get to Bellman-Ford algorithm? We start off by graphing data structure. We represent it as agency matrix. Basically, the idea we do entry row I and column J as non-zero integer and such. And then we find the arbitrage. Basically, we utilize some part of like logarithmic functions. Well, I won't dwell on this part too technical because, as you mentioned earlier, that's not our focus. But basically, if we sum up these weights, then it became negative. We can conclude that currency arbitrage exists there. Where does our Bellman-Ford comes to work? Well, it makes it easy for us to detect negative weight cycles. And the algorithm itself will be used so that we can find the shortest path consisting of at most I edges. When do we know we get that arbitrage? Well, once shortest path have been identified, the algorithms will look all edges and then looks for edges continuously. Then we get the value decreased to the shortest path. Once we can relax all the edges there, a negative weight cycle will be found. And by that means, we've acquired our arbitrage. And just to give you a quick example, basically you can see this graph besides. Think when we have 1000 US dollars and then we see this rate and we want to convert to euros. So we then buy and get the 741 euros, right? Then we see that we want to convert from this euro into Canadian dollar. So we multiply by the rate, which is 1.3666, where we'll get that 1012 Canadian dollars. Then to get back to our profit, just convert it back to US dollar. Well, we'll get more money. It's $1,007. So by that means we get a plus $7 something dollar. Basically, that's it. So what I can conclude is that we know how Forex works. And oftentimes people say it's gambling and such. Well, if more people knew how we can utilize this, I think more people can maintain the risk that's coming from it. So yeah, that's basically my presentation. Thank you.
Yeah, okay, nice one. It's very interesting, Irsan, with your presentation. So I have one also a question for you. So what your perception about the arbitrage opportunity? It is something that you think is normal, or or what do you think about it?
Well, I think it is interesting to know that a certain performance can be made. I think I didn't know when I was I do forex, but I didn't know earlier that we can actually utilize this CS algorithm. I mean, if I knew it already, then I probably have secured some more dollars than what I do so far. Because like as you know, the risk it's that high, right? So I guess it's interesting to know how CS can actually be implemented in a way that can, it's not only theoretical in a way, but it actually can save us a lot of money. So yeah, I think it's interesting to learn about this.
Yeah. Yeah, I think I agree with you, Irsan, to know about it. And then when we bring this discussion into more higher level, like let's say in the country level, I think as nation, as country, we do the same thing, yeah, to especially to make our, for example, our currency more stronger, for example. So I think that would be also the impact or one of the strategy that should be taken to ensure that we also have same same level with the other countries. So and then the opportunity will be will be somehow will be increasing, somehow it will be decreasing based on some of the economic factor and political factor and so on. But I remember one article in the South Africa about how the South Africans country try to survive with doing the same thing. Yeah, so that I think that will be in this case we can see that the algorithm is also is used for leveraging the opportunity, yeah, in the economic way, yeah, and then make some yeah, in the case is make some money, and then the money will be used for supporting the nation life, and then and etc. So I think that also one of the important things. And then when we relate it with the another, for example, with the economic things or economic subject, I think we will find a lot of things, yeah, about the concept of the algorithm that used for this purpose. Yeah, so I think that would be good enough. Okay, thank you, Irsan, for the insight. Yeah, so this is it's very interesting. You a student, you also have some it's not like computer science things, but you do that one. So I think that's good. Okay, thank you very much. Okay, anyone want to share again after Irsan? It's only four people want to share this one. Anyone? No? Or maybe I will choose, yeah, with the with okay, Pandya. Huh? Pandya, you already chosen by Yusuf. Is voluntary or is something like mandatory? Okay, mandatory. Okay, Pandya, are you willing to share with us? Okay, I also believe his work will be very interesting. Okay, so let's see. Pandya, are you in here? Or he? Okay.
Yeah, okay, sir. Let me present my screen first.
Yeah, I think you already trapped by your friend and me. Sorry. Yeah.
Yeah, it's okay, sir.
Very interesting. Yeah. I used to it. So yeah, I think that's nice. Even if we are doing online, but you still can do something that's very fun. I think that's fun.
So my algorithm today that will save the world is convolutional neural network. So what is convolutional neural network, or CNN? So CNN are complex feed-forward neural networks. So CNNs are used for image classification and recognition because of its high accuracy. So the CNN follows a hierarchical model, which works on building a network like a funnel, and finally gives out a fully connected layer where all the neurons are connected to each other and the output is processed. So the image below is an example of a CNN architecture called VGG19, I believe. It's an evolution of VGG16 and previously from AlexNet. So this is from the ImageNet competition. So as you can see, it's like a funnel where you have an input layer, and then you have either a convolution layer or a max pooling layer, and then each of the layers has an activation function, either rectified linear unit or ReLU, or a softmax function. Usually the ReLU activation are used when we are training the nodes, and softmax are used for the output layer. So why do we use CNN? So CNNs are very effective in reducing the number of parameters without losing on the quality of the models. So images have high dimensionality, as each pixel is considered as a feature, which suits the above described abilities of CNN. And also CNN were developed keeping images into consideration, but have achieved benchmarks in also text processing. So CNNs are trained to identify the edges of objects in any image. So how can CNN save the world? So it is a popular subject among academics that we can detect COVID-19 from chest X-ray, from pneumonia chest X-ray to detect COVID-19. So there has been some discussion among academics that maybe because CNN are so good at image detection that maybe can detect the COVID-19 from pneumonia chest X-rays. So there's some papers that discuss this topic. And so, for example, we can test it ourselves. So in Kaggle, I believe there's a data set of chest X-rays. So you have the normal healthy chest X-ray and chest X-ray whose people can for people who contracted pneumonia. And the chest X-ray that the pneumonia chest X-ray that actually has COVID-19 are obtained from GitHub. So if we were to do this task, we would have to have a normal chest X-ray and then a pneumonia chest X-ray, and finally on top of the pneumonia chest X-ray, pneumonia that has COVID-19, because I believe COVID-19 also in some cases causes pneumonia as well. But it's not really supported yet. There's so many pros and cons. For example, one paper cited that, however, many prediction models for diagnosis and prognosis of COVID-19 infection are high risk of bias and model overfitting, as well as poorly reported their algebra performance in being likely optimistic. In other paper also, however, models trained solely on this data do not generalize well when new data with diverse variations, either to acquisitions or disease, are encountered. So we treat such variations as instances of incomplete data and propose to impute such missing information using the latent representations obtained using a variational encoder. But they think some think that AI-assisted diagnosis are generally moving toward a better way. For example, indeed, while some AI-assisted tools might be powerful, they do not replace clinical judgment, and their diagnostic performance cannot be assessed or claimed without proper clinical trial. And we showed that these protocols might be biased and learn to predict features and depend more on the source data set than they do on the relevant medical information. So they suggested that some solution to find new protocol and method to evaluate its biasness. So I think bottom line, the main problem seems to be overfitting and thus poor generalization and also some biasness. But I think when we have more data and we have better CNN architecture, believe this is a viable option for detecting COVID cases. So that's my presentation. Thank you for tuning in. And sir, if you have any question, I would be glad to answer it.
Okay, thank you, Pandya. That's very interesting and very related with our situation today. So I think your friend already asked about the opportunity to have a question. Please, anyone want to have some discussion or question to Pandya?
Okay, I have a question. So it is interesting that I know that this is from a certain paper. So 99% accuracy in detecting the COVID-19 virus. So that is really interesting. But again, we need to justify the cost of the X-ray scan and also the fact that it is X-ray scan. So so yeah, how do we justify that? I mean, it is great, 99% accuracy, but it is costly and it requires an X-ray scan.
Yeah, I think this model are not for everyday people. I think it's meant to be used by the medical community. And yeah, it's true that we need a chest X-ray, which is costly, and not everyone has access to a chest X-ray. So that's why the available data is actually open source data, and I believe maybe hospitals has like internal data sets with which they do not share, but maybe they have a lot more data than the open source one. So yeah, I believe the medical I think it's meant more towards the medical community. So yeah, it is costly, but if it's properly, I think it can be a viable way to detect COVID-19.
Do you think that it can be implemented as like the first phase, like oh maybe do I have COVID virus? So then we can take this. This, or it's like phase 2, where maybe you have tested positive on phase 1. And then...
Oh yeah, I understand. Yeah, honestly, I think this is not a viable way for the phase 1 detection. I think using PCR and antigen testing is way more easier and also cheaper. But I think this COVID detection using X-ray is just like science for science's sake. So it's not really like practical. It's just maybe in the future when maybe chest X-rays are more available and it's less costly. I think when maybe in the future we have some diseases that only can be detected using chest X-ray, and we can't use the swab test. Yeah, maybe when the time comes it will be useful, but yeah, I think currently it's just science for science's sake, so not really practical, but it's just fun to toy around with the available data set, I guess.
Okay. Thank you,
thank
Pandya. Okay, thank you very much. I think Pandya give us a best example, how the approach on the computer science is try to handle the issue on the current issue, especially on the COVID-19 detection issue, which is, of course, the process itself, the data, which is the image of the X-ray, is not easy to make by the person, for example. But I think the issue is same with the issue of for example, in our university, introduce the genus screening test. So I think it's same. The issue. The issue is about the cost, of course, and then about the accuracy of the AI performance and so on. So I think that would be also the issue. But yeah, I'm interested with your statement, Pandya, about when the time is come. I think it will be will be will be the goals. Yeah, it will be happen. So I think the pandemic pushed this situation to go there. Yeah, but when I think about in the philosophical way, I think we can see how the how the computer science can do some extraordinary approach to maybe it's not maybe not comply with the medical things but I think that will be the breakthrough. So I think Pandya is not show the only one things here. If I want, I a little bit tell a story. I also do the same thing, but using the tongue, using the lidah. So I learned from the people from the Papua when they sick, they only check to the doctor and only show the lidah, and then if the doctor will be see the form, the color of the lidah, and then they can detect what the type of the disease that they have, and then they do the treatment. So that's happened in Papua, and so why we not use that one for the COVID-19 detection, for example. So now I am in the lab in computers network lab. I do that things still in the collecting. Now I have about more than 500 data set, and the accuracy, but still on the about 67% accuracy. So yeah, it's still very low. And then we still try to get the access to the hospital to have the patient tongue image, especially for the COVID-19 image. But unfortunately, it's very difficult because we need to comply with the NDA things and so on. But I think that's the philosophy work. If we have some dream, if we have some imagination, we have to solve something in the world. I think that that we need to be one the most important reason why we need to develop some approach in the computer science, which is algorithm, application, or anything else. I think that would be nice. Thank you, Pandya, for the insightful presentation.
Okay, you're welcome, sir. Thank you very much.
Okay, thank you for also give the question. Okay. Oh, we missed the time. I think we already have extra time, 2 minutes. Sorry for today, because I think it's very nice to learn about your insight about your finding and how you formalize the philosophy of the algorithm into something that will be save the world in your perspective. So I think a lot of lesson learned that we can learn from that. So I think I will download all the presentation and then of course give the score to the ELOC. But I think if I will try to share with you, maybe I will give the link so all of you can learn can learn from another student about what they're finding. So that will be the good point. So okay, I think our time is up, and we'll continue next week. And for next week, we will do some case study. So feel free to join again this session, and then we will have some exercise on the online class. I will bring some case study. It can be some video. It can be some people. I will invite to the class and then share some story, and then we will try to discuss with them about the philosophical thing about the issue. So of course, in the perspective on the computer science. So hopefully the guests can be joined with us and then share with you a lot of things about the philosophy on the computer science. Okay, thank you very much for all of you, and have a nice day. And I close the session. Assalamualaikum warahmatullahi wabarakatuh. Oh, sorry, Fakih, what do you want?
Mohon maaf Pak, tadi saya belum sempat absen, bagaimana ya Pak?
Yes. Can you scan? Okay, so wait. So for you that not scanned yet, please scan. If you have done, you can left this room. Thank you very much. See you next week.
Thank you, sir.
Thank you. Oke, yang manual tuliskan di chat ya. Nanti saya akan manualkan.